Hey, hello and welcome to today's GFG problem of the day. Hope you're doing well. So let's say today's problem, serialize and deserialize a binary tree. Okay. So what the problem is saying is we'll be given a binary tree and we want to do two operations. One is serializing and another is deserializing. Okay. So what does the problem say? What is serialize, right? So serialize is to store the tree into an array and return the array. Okay. And deserialize is deserialize the array to the tree and return the root of the tree. Okay. So what does this mean? So serialize, what the problem is saying is we want to convert the tree into an array. Okay, into an array. We'll see how. And okay, and deserialize is again converting the array back to the tree. Okay, so that's what these two operations are. Okay, now when does this serialization and deserialization come into picture? Okay, so for example, you have a binary tree and you want to transmit or transfer this binary tree over the network through REST API or through like Kafka topic or any messaging queue, right? Any messaging queue or any topic. Okay, or you want to store this particular tree into DB. Okay, so during that time, this serialization comes handy. Okay. So now let's see how will serialize this array. For example, so here we have a binary tree. Okay, what we are going to do here is we are going to run the pre-order traversal. Okay, and we are going to insert the elements in pre-order fashion. So we are going to start from the root. Okay, so first of all, we are going to ingest 10. Okay, then we are going to go to the left. We are going to ingest 20. We are going to go to the left. We are going to ingest 40. Okay, we are going to go to the left. We are going to ingest -1 when there's no child. When there's no child, we're going to ingest -1. We go back, we go to the right child, we're going to ingest -1. We go back, okay, we go back, we are done processing the left child of 20. We go to the right of 20 now, we ingest 60, right? There's no left child of 60, we ingest -1, no right child, -1, right? We go back, we're done processing both the children of 20, that is left and right child. We go back, we are done processing the left child of 10. Okay, now we go to the right side. Okay, right child of 10, we ingest 30. There's no left child, we just -1. There's no right child, we ingest -1. So this is our, okay, so this is how we have serialized our binary tree into an array. Okay, into an array. This is how we have serialized the binary tree. Okay, now we also want to deserialize, right? We also want to deserialize the binary, deserialize this array and form a binary tree out of it. So what we're going to do, we are going to again, uh, so we are going to have an index I. For example, we are going to iterate through this array and we're going to form the binary tree out of it. So let's see how. So what are we going to do here? So we will first form a node. We are just forming nodes. We are not assigning any left right child for now. Okay. So we have created a node 10. Now we go to the next I, we increment I, we create 20. Okay. Okay, we create 40. We are just creating the nodes. We created 40. We incremented I. Now, when there is -1, right? When there's -1, first of all, we are simply going to increment I and we are going to return null. Okay, we're going to return null. Okay, so when we return null, okay, when we return null, so whatever node was previously created, right? Whatever node was previously created, we assign the assign this null to the left child of that particular node. Okay, now we come back, like there's an I. Okay, again it is -1. We are going to create null out of this. We are going to create null out of this. Okay, and we are going to assign now this time to the right child of the previous node, which is a, yeah, of the node of the last node we created. Okay, now we also like incremented this I, right? Okay, we also incremented this I. Now, since we have created, okay, we what we did now, we create, like there was null, we assigned to the left child of this new node, and again we found null, we assigned to the right child of new node, and we now go back. We now unwind the stack. So when we have unwinded, we assign whatever was the previous node created, we assign whatever is a node returned, right, to the left child. Okay, to the left child. Okay, now what we do, now we'll create this node again. Okay, I think it will be clear to you. Just be with me. It will be clear to you when we code. Okay, so here we have We created 60. Okay, we created 60. We incremented I. Okay, again there's -1. We're going to create null. Okay, when we create we return run, we are going to return null, right? And when we return null, before that we are also going to increment I. Okay, now when we return null, we are going to assign to the left child of, we are going to assign this null to the left child of the new node created, right? And then we are going to create null again, like we are going to, before returning the null, we are also, whenever we encounter -1, right? We increment I first, we return null, and then this time we are going to assign this null to the right child of the previous node created. Okay. Now we are done. We are done with this. Now we are going to unwind the stack. We're going to go back. We're going to return this particular node to this particular node. Okay. To the right child of 20. This particular node to the right child of 20. Okay. We are also done with the uh, right, we are also done with the with this particular node, right? So we are going to return this node to the left child of 10, this node to the left child of 10. Okay, now we have a 30. We are going to create a node 30. We are just creating a node 30 for now. Okay, then we are going to increment our I is pointing at -1. We are going to first increment our I again. We are going to first increment our I. We are going to return null. Okay, so when null is returned, it will be assigned to the left child of 10, 30. Assigned to the left child of 30. Okay, again we encounter -1. We are going to increment I, right? We are going to return null, and this null will be returned to the assigned to the right child of 30. Okay, okay, and again we are unwinding the stack. Okay, 30 is done. So we will return this 30, and it will be sent to the right channel of 10. Okay, and we are done. Since I we are done with the I. Okay, and we are going to return this root node back. Okay, I hope you've got the intuition. I think it will be clear to you when we code. Okay, just before going to the code, I'll request you, please subscribe to the channel, like the video. Okay, so let's see. So first of all, first I'll show the Java code followed by C++. So we have our array list here. Array equal to, let's call it array list. We are going to write a overload method, serialize. We're going to pass root and this add, and finally we're going to return this add. Okay, now let's implement void serialize node root array list integer add. Okay, array list integer add. Okay, so first of all, what we're going to do? First of all, what we're going to do? We'll assign whatever is a add. Will insert, right, whatever is the root dot data into this array. Okay, then what are we going to do? We are going to go to the left. We are going to go to the left, root dot left array. We are going to go to the right. Okay, now when root is null, we are going to add -1 to that, and we are going to return from here. We're going to return from here. Okay, now what we are going to do? Okay, now what we did here is we serialize, right? Okay, all right, I've already explained this. We are inserting the elements in the list in pre-order fashion, right? First we are inserting the, or we are processing the root node or inserting the root data into array. Then we are going to the left, then we are going to the right. Okay, so we have done this function will serialize add into the array, and we are returning the array. Now same array will be passed into this deserialize function. Now let's see how we can. So what are we going to do? We are going to create an index array of size 1. we are we are creating an array because we want some value in the index, right? We want to increment the value. Okay, and that incremental value should be persistent. That is why we are taking this array size 1. Okay, array size 1. So let's again write a function, deserialize deserialize. We're going to pass this array. We're going to pass this index. Okay. Now let's node deserialize, and also we are going to return. Let's return this. Okay. This will return the root node. Okay, of the binary tree formed. Okay. Now, first of all, we have array, right? Array list integer ar int index. Okay, so first of all, what are we going to do? We are going to create a node, new node equal to node, right? Air dot get index of 0. That means whatever, now index of 0, it stores what? 0, basically. So by default, this array is initialized with 0. Okay, this array is initialized with 0. That means this index of 0 will return 0, and air dot get I will return the first element, right? Return the first element. It will create a node of the from the first element. Okay. Now we have created the node. We are also going to increment index of 0, right? That is, now index of 0 will hold 1. Okay, hold 1. Okay. Now what are we going to do? We are going to run recursion new node dot left. Okay, new node dot left equal to, we will call this deserialize function again. Okay, we are doing DFS basically, the def first traversal, array and index. Okay. Okay. So whatever is a node created, now what we are going to do, this index we have incremented here, right? So this will call the function again. It will create a new node, right? And this index of 0 this time will return 1. And this will, the new node will be created out of the second value in the list or array, the second value in the array. Okay. So similarly, what we are going to do, new node, right? Return new, return new node. If index, for example, now what will be the base condition? If add dot get, if add dot get index of 0, if it is -1, if it is -1, then what we are going to do, we are going to first of all increment index of 0. Okay, and we are going to return null. So we have seen this, we are going to return null. Okay, so this null return, right? For example, it was called from here, right? This deserialize, and when we call this array of get, it was -1, we incremented I, that is index, and then we are returning null. So this null will be assigned to the left of new node. Okay. Okay, so in this way we implement the serialize and deserialize functions. I hope you have got the solution. Let's submit this. Thanks for watching. Please don't forget to subscribe to the channel, like the video. Okay, let's quickly see the C++ code. Okay, so here's the C++ code. So what we do, we took we created this vector. Okay, we call the serialize function, right? Now we are ingesting the elements in pre-order fashion. So we inserted the root element into the array. We went to the left of root. We went to the right of root, right? And what is the, for example, if there's no child, we are inserting -1 into the array and we are returning. Okay. And then we call our deserialize function. Where's the deserialize? So the same array is passed into this function. This is index 0. We'll pass by reference. We are calling this deserialize function. Okay. Here we have our new node created. Okay. We'll first create the new node out of the current index, and then once that index is used, we are going to increment that. Okay, we are calling this deserialize with the incremented index. Okay, and here, for example, if it is -1, if it is -1, we are going to increment index, and then we are going to return null ptr. So from wherever it was called, for example, it was called from here and it returned null ptr here, right? So it will be that null will be assigned to the right child of new node. Okay, once this both, for example, for a particular node, if these to both the nodes. If both these function calls are done, right, then we are return the new node to the parent node now, to the parent node. So it's like unwinding the stack. Okay. So I hope you got the solution. I'll attach the code in the description section. Thanks for watching. I wish you a very happy, healthy, wealthy, and a great day. Please subscribe to the channel, like the video. Okay. Thank you so much.